All right, so for this video, you're going to want to also have your notes open because we're going to take some notes. So get your Unit 1 virtual notebook, your geology notebook out, and you might want to try doing that, one side of your window, have two windows. One side be the movie and the other side be your notes so that you can, look at both at the same time. But if not, you can switch tabs, you can pause the video, and it's going to stop from now and then as well. So we're talking about convection in the earth. We're trying to explain why convection in the earth could actually move continents and how that works. And we're going to have to look inside the earth to do that. So here's a diagram that explains a lot of things. And I want you to try to tell me something that you can explain in that diagram and then something you have a question about. So go ahead and write that. So this little movie, I really like this movie a lot because it shows that convection happening in there. It shows the hot core of the earth, and it shows the movement of the mantle, and it shows everything really well. So let's check this out.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart, and it's this that ultimately causes the continents to move.
So pretty cool, I think. I like that video because it really shows what's happening underneath the earth. And here's a sort of the same thing, but it's not a video. But you can see that convection going around, and it's the top crust that sort of floats on top of that convection. So there really are, I'm going to move this over here because we don't need this spot, but I do want to look at you guys. So there are two kinds of crust. And when we talk about crust, we're talking about the very, very, very top of the earth. It's much thinner than that purple line, but that's the crust. And there's two kinds. All right, there's oceanic crust. That's all the crust, the rock, not the water, because the water's on top. But the rock under the water is either, that's oceanic crust in the oceans, and then on the land is actually different. That's continental crust. And there's a reason why they're different. So we're going to talk about those two differences. So let's write these in our notes. Oceanic crust, you can see, is what? It's pretty thin. It's thin. It's very dense. So for its size, it's very, very heavy. It's got a lot of matter in it, very dense rock. It's also new. We know that's new because that's where all the old, new rock gets made, in the middle of the oceans. All ocean rock is new, relatively new. I think the oldest ocean is only 200 million years old. But then we have the continental rock, and you can see the continental crust from the continents, crust from the land, is what? Well, you can see it's thicker, right? In every way, it's totally opposite. So it's not dense, it's less dense. It's still rock, so it's pretty dense. And it's old. Continental crust can be 3 billion years old, as opposed to hundreds of millions. So continental crust gets really old. I'm going to move myself over here. So what can happen to these? What can happen to these kinds of crusts? If everything's moving around, aren't they going to bump into each other now and then? And if they bump into each other, there's a couple possibilities. So either crust can move apart from each other. We're going to call that divergent. Wherever two pieces of crust are moving away from each other, like seafloor spreading, we're going to call that divergent. That's moving away from each other. New word. Convergent is when they're coming together. All right? So when they're moving toward each other, we're going to call those convergent. And these are boundaries. So if the Earth is made up of all these plates moving around independently, sometimes they're going to hit each other. That's a convergent boundary. Sometimes they're going to be divergent, which means they're moving away from each other. And sometimes they can slide by each other. That's called transform, but I don't have that on here. So boundary types, this is going to be important. So underneath in those same bit of notes, we have the divergent and convergent, but we have divergent boundaries. They have them moving apart from each other. So go ahead and draw that. But then as far as convergent, we could have two continental crusts coming together. We could have two oceanic crusts coming together. And we could have a continental crust and an oceanic crust coming together. Those are three different possibilities. But in every case, they're converging. And what we're going to try to do is find out where on Earth are these things happening. Now, we can't see it happening, but there's surface features that are going to show us, there are going to be some evidence. So that's the next step, is to figure out what kind of surface features would we expect to see at each one of these boundaries. And that's it.